I started researching the science behind feedback loops recently, and I've kind of never really studied feedback loops at university. When I started studying, there was basically a choice of either going for electrical engineering or maths, and I went for maths, and I never really got deep into the science of feedback loops, and I started reading books about that recently, and I'm fascinated how much the software industry has been reinventing stuff that was invented 100 years ago, and how naively we're approaching the whole science of feedback, which can have some really disastrous consequences. For example, one of the things I'm going to be talking about tomorrow is this Sentinel rewrite of the FBI case management system that went so wrong that the program manager wrote a paper published in IEEE by the title, Why FBI Cannot Deliver a Case Management System, where they published a request for proposals. Lockheed Martin, I think, won with a bid of $90 million, and $90 million later, they realized it's just never going to be finished. So they canceled that, and they decided to do it again, but do it iteratively, where every month they had the choice of basically deciding we want to cancel this, it's not really going to work out. And the outcome of that was that they spent $360 million figuring that it's not going to come together. And there's a big question of why did it take 4 times more money and time to learn that something's not going okay, where you have feedback every month, compared to just a big waterfall system. And that's because our industry is taking feedback very naively. There's a famous case study from the BBC here, where after spending £75 million, a project was cancelled, and there was an investigation by the National Audit Office, and they concluded that they could spend so much money without delivering any business value because it was agile, which meant that whatever they delivered had value because, why not? And I think as an industry, we are approaching feedback very naively, and we can get a lot more value by not ignoring all this research and all this science that's gone into figuring out how to create good feedback loops, because that knowledge is there. So that's kind of what I'll be talking about.
That's awesome.
Well, I hope people will take away from my session tomorrow the idea that by figuring out what to measure and how to measure it, and how to act on these things, they can speed up feedback loops, they can get more relevant feedback loops, because feedback loops have been in software forever. Even from the first software project, we had some people delivering something and then customers presuming being disappointed with what was delivered, if statistics are right, and then having to go back and fix stuff and re-engineer stuff. And we've implemented lots and lots of micro-feedback loops, starting from linters and IDs that give us feedback that we're mistyping something, and spell checkers and fast compilers and all this other stuff. But we are not really good at managing those feedback loops. And we're getting into the position in our industry where we have so much technology to now measure things like deployment times and metrics and error rates, and there's this whole industry of observability and monitoring that's emerging. And my worry is that most people don't really get the value out of that because they're approaching this whole thing very naively. So I want to kind of give them some hints how they can create better feedback loops, even from a kind of micro feedback loop perspective, on minute-long coding cycles or second-long feedback cycles, to these much longer, are we doing the right thing and are we doing it correctly perspectives. I mean, my favorite story from humans versus computers is how things go wrong where people try to assume that missing data is no data, and how different assumptions around what it means for data to be missing kind of propagate through different computer systems. So there was this guy, I forgot his name, but he was an IT person. He sold his company somewhere in California a while ago. And basically what Californians do when they sell a company is they buy an expensive car and they buy a boat and they start kind of fishing and sailing and things like that. So, of course, if you're rich, you want to get vanity plates. And he went to get vanity license plates, and the web form or whatever the form where you need to enter your choice had 3 choices you need to fill in. So he put in boating and sailing because that was on his mind, but he couldn't remember anything else. So he put in no plates as the 3rd option, like don't give me anything if I kind of don't get one of these 2 choices, because they didn't exist in the system. And of course, boating and sailing were taken, but he got no plates, like plates that said no plates. And being a software person, that seemed fun enough, so he decided to keep it. And then a while later, he started getting parking tickets from all over California, because whenever the parking attendants wanted to issue a parking ticket and the car did not have plates, because the software didn't have an option, like this car doesn't have plates, they would type in something, and one of the things they would type in was no plates. So this guy started getting literally thousands of parking tickets and had to spend all his time in court fighting these tickets because, he thought it's fun to do these things. And there's, he's not alone. There's lots and lots of people who made curious choices like that. There was a guy who decided to have plates for test and ended up being issued a ton of parking tickets that people were testing in production by issuing tickets for test. There was another person who decided, I think he was a software developer, he got a license plate for Void. And at some point, that was all fine up until a few years later. They upgraded the court software systems, and then whenever a judge would void a ticket, they would basically re-enter the ticket, but instead of using the license plate number there, they would enter void as a license plate. So kind of these mistaken assumptions about what it means for something to be missing are absolutely amazing. For me, software craftsmanship means that this is a technique or knowledge that you have to learn on the job from people who've done it before. As opposed to this thing being a science that you can, study at a university and then have proper scientific methods around what's right or wrong, or engineering where you need detailed process constraints and I guess there is a method to the madness where software craftsmanship for me means basically the only way to truly learn how to do this stuff is to kind of do it over and over and over and over and over and over again and just become better at it. And I think kind of that's a reaction to maybe all these process heavy and role heavy and UML heavy things that happened in late 90s or maybe early 2000s where software was more kind of engineering or, I guess 70s where people wore lab coats to do software. For me, the key thing about craftsmanship is where the teaching method of craft was basically learning from, working in a shop as an apprentice and then becoming a journeyman and then hopefully becoming a master. And that's, the Pragmatic Programmer book that's now getting its 20th year edition, I think, was one of the most influential books I read or at least when I was starting out. And they have this subtitle from journeyman to master, which was really kind of explaining this whole learning model as well. Our industry is, I think, interesting from a perspective of things being very cyclical and kind of the history repeating itself over and over and over and over. And we have these trends that are emerging every 10 years where people are reinventing things again and again. And although that might sound like we're going around in circles, I think we're actually kind of going in a spiral that's going up. Yes, we are revisiting the same themes over and over again. And I think one of the topics that's really emerged over the last 10 years that's potentially new, not something that's been there before, at least not the way I understand early literature from like 20 years ago or 30 years ago, is this whole concept of continuous delivery. I think Kent Beck wrote about continuous integration in his book, but continuous integration was more resolving technical problems by frequently bringing people. And actually in Kent Beck's book, if I remember correctly, he was talking about pairs of people using a single machine to integrate on it. And now we have these elaborate pipelines that kind of are trying to prove that an artifact is ready to proceed from one way to another. And going back to the theme of observability and metrics and feedback loops and measurements, I think modern deployment platforms are allowing us to do interesting experiments where we can, deploy a new version and see, is it actually increasing or decreasing sales? Is something interesting going on that 5 years ago were accessible to companies like Google and Facebook and Amazon, but now they're accessible to even two-person teams because the technology has advanced so much. So I think that whole theme of tying together kind of continuous delivery, not just deployment, not just integration, but actually delivery to the client and closing this whole process and integrating it is a topic that I don't think it existed 15 years ago, definitely 10 years ago, maybe in very, very large, very fast, successful organizations like Amazon and Google and Facebook, but now it's getting propagated to, the early majority of the industry. The best feedback I've ever been given was when I was working on an energy trading system, and we spent an insane amount of time, at least in terms of the project length or how much time we were given for the whole thing, that was to build a algorithm that would optimize the reporting of energy trades. Energy trades are curious from a perspective of, electricity energy trading is curious from the perspective of, there's no warehousing really. And physics tell the electricity where to go, but the traders created some abstractions around what is traded where and what is transited where. So if you sell, for example, electricity from England to Italy, you can say it went through France and then Italy, or you can say, well, it went to Belgium and then Germany and then Austria and then Italy. It's really up to you how you say it, because the physics are the same and everything has to add up anyway. So there's a lot you can do kind of to do short-term contracts, long-term contracts and things like that, and then optimize how much you're paying for transit. So I actually invented a new algorithm for transit optimizations, spent months doing research on this, and I was really happy that this was my one time after university to be able to actually apply this theoretical computing knowledge. And just in order to be able to test what's going on, we created like a visual map of Europe where this thing would be plotted out, where your electricity went. And about one day before we were showing the final version to the client, I decided I'm going to just put a proper map of Europe behind it. I'm not kind of going to do random lines there. And then we explained the algorithm. We talked about all the science behind it, and then I pressed the button. Vroom, you have this spreadsheet and then a map of Europe with lines that are red and blue. And all the traders are like, oh, this is amazing. I've never, seen anything like this. This was the best software we've ever seen. And actually, it turns out that the whole algorithm thing was utter bullshit, because they didn't need that. They would kind of, just type it in manually because they had these long-term contracts. But being able to visualize what they typed in was absolutely amazing. And they were, this one, I don't know whether to call it eye candy or something like that, won everything that we needed to do there for years later, because they were so impressed by that. But it was like a 5-minute hack. So I realized how sometimes, a 5-minute hack can be much, much better if it helps people do something they actually needed to do than months of really hardcore programming and optimizations of algorithms because we didn't really understand the problem these people had. We jumped into the opportunity of doing something complicated, assuming that that's what they needed, instead of actually talking to them and figuring out that they, don't need this complex optimization thing. They just need to see where things are going so they can optimize it a bit better. So that's my most kind of, the thing that was etched in my head after that is don't overcomplicate things. Make sure you talk to people. And we instead of spending months and months building something that actually they didn't end up using, maybe be smarter about that. Networking, community, and generally I think conferences like SC London next year are allowing people to keep the pulse on a very important topic that's emerging. So I've noticed that there's a bunch of people that were talking here that talked last year as well. So, it's interesting to see how their ideas progress. And I think attending conferences like this is a great opportunity to exchange ideas primarily for me.